So this is part 2 of our domain and range and relations videos. So we're still looking at that, but our success criteria have changed a little bit for this one. So we want to be able to sketch a graph when we're given an equation or a relation, the specified range and domain, and to identify an implied domain for a relation. We'll go for what that is in a second. So we're going to have 2 questions here, but first we want to sketch a graph of this first relation and state its domain and range. So this graph, we're looking at it and we can see it's just a set of points. So we can put in our little set of axes. And obviously you're going to want to label these with your little arrows, your X, Y, and we're going to want to scale. So let's say 1, where does this go to? -2 up to 1. It's just 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. That's all we're going to need. So we've got the point -2, -1. So -2, -1. -1, -1. -1, +1. 0, 1, and 1, -1. So you can see this isn't going to really form any kind of graph. It's just a set of points. Our domain here is going to be just the set of x values. So we've got -2, -1, 0, and 1. And our range is our set of y values. So we have -1 and 1. Okay, that's the entire range because there's only those 2 points on your y-axis where there's 4 points on your x-axis. This equation here, so remember we're looking at this, it's being written as an equation rather than in that set notation we were looking at before. We've got 2x plus 3y equals 6, where x is greater than 0. So that's meaning only the positive numbers of this equation. The easiest thing to do is to turn that into a linear equation or just work out where your intercepts are. So our x-intercept here, so when y is 0, so that's going to be 2x plus 3 times 0 equals 6. So 2x plus 0, it's just 2x equals 6. So x equals 6 divided by 2, which is 3. So when y is 0, x is going to be 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And our y-intercept when x is 0 is going to be 3y equals 6. So y equals 2. So when x is 0, y is 2. That's going to be there. So that line is effectively just going to be going like that. However, we know that it starts at that point there because x has to be greater than 0. So anything that is over here does not exist in this line. So it goes down like that. Now, this dot here, we actually put that in and it needs to be a solid dot. So not like an open, not a circle, it needs to be a solid dot. And that's indicating that it can be equal to that value. So as I've said just here, the closed circle says that that number is included. Open circle means that it's not included. So that's like your square and round brackets in your set notation. If we sketch this quadratic here, oops, not this one. So if we think about this just in terms of those quadratic transformations that you would have learned last year, x squared plus 2 is effectively just the graph of x squared, but moved up vertically by 2. So we know that it's going to go and intercept at the point there, 2, and it's going to go like that. Nice quadratic. But we have a defined domain here. So we're saying this graph is only going to exist between x at -2 and +1. So -2 being here, and we've got the solid dot because we've got the equals, and +1 there. This is just a sketch. You probably want to do this a little bit neater in your book. So basically, it'll erase the whole line if I try to, but we're going to imagine that bit doesn't exist and that bit doesn't exist. So really, we would just have a graph that looks like that with our 2 dots, okay? Because we've specified the particular domain for that function, or for that equation rather. Now, we can have something that's called a maximal or an implied domain. So when when some kind of equation is written without a domain being specified, we assume that the domain for that relation is as large as it can be while still having meaning for the rule. Okay, so we call that the maximal domain or the implied domain. It can be called either. So if we were just to sketch the parabola of x squared, the domain of that is infinite, right? It is just, it's R. It's the set of all the real values because they can keep going forever and ever and ever and ever and ever. Any x value you pick, there will be corresponding value of y for it. If we were to sketch a circle, so this circle here is given by this function, this equation rather. So this is x minus 1 squared plus y squared equals 9. So it's a circle with its center at the point 1, 0 and a radius of 3. The implied domain, or the maximal domain, becomes -2 and 4. So given there with our interval notation that we learnt before. And the range is -3 to 3. Because outside those values, so anywhere past 4, going out that way in the x, the function, the relation doesn't exist, right? There is no part of the relation that exists outside that. So the domain that is being implied by that equation is that x is between -2 and 4, and that the y values are between -3 and +3. It literally cannot go outside those values because it doesn't exist. It has no meaning outside that. There you go. Now you understand all of the things about maximal implied domain. So you can sketch a graph within particular bounds and identify an implied or maximal domain for a relation.